Here's a good question. Why we move a term from one side to another, we have to change the sign. Okay, so this is a good question. Let me mention a few rules you have to follow when you solve the equation. That's not the rule we set at the very beginning. When you move term from left to the right, you have to change the sign. Okay. First of all, yeah, we have the equation, right? Equation usually it's written like A equals B, right? Now this equation is equivalent to if we add or minus subtract a term, you still get the same equation essentially. So those two equations are similar, are equivalent. So if we add or subtract the number to both sides of the equation, you keep the balance, right? Just like a scale, you put the identical terms to the both sides. You don't change. You change the you change the form of the equation, but you don't change essentially don't change the equation itself. If you want to solve the equation, those two sides of the equation will be the, those two equations that we call equivalent. That will give you the same solution. Another one is A equals B is the same as if you multiply by a constant, you get the same equation. But then be careful, as this K cannot be 0. Okay, or you can divide both sides by K. Okay, so this is we have two basic formulas we can use to simplify the equations. All right, now. So let's see. Let's see. See some examples. Okay. So if we have an equation, okay, if you have an equation, 2x plus 3 equals 4x minus 1, right? Now,
obviously, you.
If you use this two, if you want to simplify equations using these two algebraic rules, what do? You cannot just move the term to the one side, from one side to the other side. What you do is you can add both sides by add the 1 to the both side. If you add the 1 to the both side, and then sorry, I'm good. Add the 1 to the, so this is you add it to that part, right? 4x minus 1 plus 1, okay? Actually, what they did here, you add the 1 to both sides. Then this part is canceled out. The right-hand side is canceled out, okay? So this actually is gone. It's a 0. So what you can see here is it looks like you move -1 to the left-hand side. Then it becomes positive. Actually, what you did is just using those two algebraic rules, you can actually just add the 1 to the both sides. Okay? So when you add in order to cancel -1, you have to add the 1 with the opposite sign. That's why opposite sign, if you positive negative,
consequence.
right? If a positive becomes negative, that's the reason that shows up on the left-hand side. That shows up on the left-hand side, okay? And so it's 2x, right? It's 2x plus 4.
Just make sure that I don't have a consequence.
And now you looks like you have to move 2x over to the right-hand side, right? Actually, you add, you subtract 2x from both sides, okay? Then look like you change the equation, but essentially it's not, the equation is not changed, okay? So you get 4 equals 2x, okay? Now which rule you have to use? Then you have to use the second rule, you have to divide both sides by the same number, okay? So 4 over 2 equals 2x over 2, okay? And then this is a canceled out. That's why you get 2 equals x. Okay. Yeah, this is a 2 equals x. Yeah, we are not going to just explain to you why, you know, we have to change the sign when you move the term from one side to the other side, okay? Because we cancel that term by adding the opposite sign of the term to both sides, okay? Right, so that's the reason. And then after that, we are not going to say, oh, we keep saying add a term to the both sides. We just say move one term to the other side, okay? And you can also say that you move 2 to the left-hand side, and actually because 2 is a coefficient of x, so that's why it should be go to under 4, right? And you can also say that, right? If you want to get rid of 2 in 2x, then you have to move 2 to the left-hand side. But when you say move, you have to go to denominator. But actually, what you did here is you divide this equation by 2 on both sides. Okay. All right. Now, what are we going to today? What am I going to do today is we are going to continue study linear equations, but we are going to deal with the fractions. Okay, coefficients of fractions. Okay. So here's a question. If we have 1/3 of x equals 9, for example, right? Now this equation, yes, this is it's a very simple equation, and by fractions, the coefficient is a fraction. So fractions, you involve fractions, computation would be more complicated. But let me compare with the general form, right? If you have ax equals b, right? I know x equals b over a if a, b are numbers. You can do like that, no problem. So we do that, okay, x equals 9 is on the numerator, and then divide by 1/3. But you have to simplify this expression. Remember, we did some exercise at the very beginning. So if this is in the denominator, and you have to turn this upside down, right? And then you got 27. You can do like that, no problem. Now, how do we get x equals b over a? You divide both sides by a. Okay, if I divide by both sides by a, then you get x equals b over a. But you can also case by case, right? So this 1/3 of x, I don't like fractions in the computation. So you can get rid of the fractions first before you simplify, okay? So what you do is you multiply both sides by 3, okay? Then you can get rid of this 3, okay? The left-hand side is just x, and the right-hand side is 27. You see, it's much easier to do the computation, but don't forget, you have to multiply every term by the same number, okay? Both sides, okay? Yeah, so that is a quick way to do, okay? And let me give you another question, like a 5 over 3 x equals, okay, equals 7, okay? Now, 5 over 3 is a number, right? You can think, this can be called a, okay? And 7 is b, like then you have b over a. That's a pretty complicated fraction if you want to write the answer directly, okay? So we can get rid of the fractions first, then make every coefficient as integer. Okay, what do? You multiply both sides by 3. Okay, then this 3 canceled out because they're, how do you cancel out terms, right? You have the same common, if both numbers have the same have a common factor, then in the fraction, then numerator and denominator have the same. If they have the same factor, then this factor can be canceled out. Okay, right? So only when you can do the a, b, a, c, and this a can be canceled, have a b, c. Okay, that's all. You cannot cancel a if they do not have the common factor. Okay, so if a numerator and denominator do not have the common factor, you cannot simplify. Okay, so now you get 5x equals 21. Okay, The next step is just divide both sides, right? And by 5. So it's 21 over 5. And that is good answer. You don't need to change it to a decimal number and or in other forms. We like a fraction, it's called proper fraction. Okay. Okay. We you know we don't want to write this like a 4 1/2. This is easily be confused. In elementary school, that's fine, but it looks like to me maybe 4 times 1/5, right? So we don't want to write this in the computation in the future. Okay, we prefer unless it's specified at the end. Hey, your answer should be expressed in that form, but during the computation, you shouldn't use that form. Only when at the end, you change this 21 over 5 to 4 1/5. Okay, but let's keep this. Okay. So now we're going to do a little bit complicated. Now, how do we express a fraction? Sometimes we can write x over 7. This is also viewed as like 1/7 times x. It's the same. Okay, equals x over 5. Okay. Now a problem like that. Okay. There's no constant term here. Okay. So how do you do that? There are a couple ways to do. Okay. There are a couple ways to do. So you can gather fractions first, right? So you can use one simple fraction number to multiply both sides, and you have to multiply 5 times 7. Okay, because in order to get rid of 7, that number should contain 7. In order to get rid of 5, that number should contain 5. So the smallest number containing 5 and 7 will be 35, right? So when you multiply both sides, and what do you get? Here's x over 7, right? 5 times 7 times x over 5. And then you see, this is a common fact, and this is a common fact. You cancel it out. You get 5x equals 7x. Okay? Then I say move a term to the right-hand side to the left-hand side, right? So, and what I did is actually we subtract the 5x from both sides. So this side is 0. The other side is 7x minus 5x. It looks like I moved 5x from left to the right. Actually, then change the sign. Actually, I subtract the 5x from both sides. Okay? So then I get 2x. Now x0 equals 2x. X can be 0 only. And because x is going to be 0 over 2, which is 0. Okay? Now I can see at the very beginning, I even don't need to solve it. Okay, let's go back to x over 7 over x over 5. Okay, equals x over 5. Now, how do you see that at the very beginning, solution will be 0. You can move x over 5 to the left-hand side. Okay, you get this equation, right? 1 over 7 is just a number. So it's times x, right? And here, 1 over 5, it's also x. Now, next step is we call the factoring. Okay, factoring idea. So there's a common x here. You can take it out. So it'll be 1 over 7 minus 1 over 5 x equals 0. But this number is not going to be 0, clear, because they're different, right? 1 7 is minus. So this is not going to be 0. A non-zero number times x equals 0, then must be 0. X must be 0. Why? Well, you don't need to do the computation. This is going to be 0. 0 divided by any number is going to be 0. Okay? Okay. So we were going to study a factoring a little bit later. Okay? In the next, in the following chapter. Okay? So if you use a factoring, you can solve the problem quickly sometimes. Okay, let's do the next one. Okay, so I'm going to ask you to do this problem. Okay, I'll give you a few minutes. 3 over 2x equals Yeah, 5 over 2x minus 1. Yeah, please solve this equation. So here we have this kind of equation similar to the problems we discussed in the last class, but here we have to deal with the fractions.
Baba, 他说他知道 it's no difference because 他说我可以问老师问题
Equals
which
1.
I can from home also, but she doesn't know what to say.
Any different answers?
But I've gotten every
Benjamin
single
Lu,
question
your
correct so
answer?
far. What would you?
Who is Lucas?
I've gotten every single question correct. Mama says I need some help.
好了好了，不要再说了，你上你的课好吗？
No, don't say anything. No. They're just like,
You all get answers? Anderson, yeah. 1/2. 1/2. We have different answers now.
okay. English.
Alice?
Silence.
You have answer? No yet? Okay, so my hint is, double check your work, okay? If you get 1/2, double check your work. You can find out where you make mistakes. I hope you can find out by yourself. So, Rainier, do you have answer?
今天先
Are you
不给你
sure?
考试啊，
X equals 1?
等会儿回来爸爸要跟你讲话。
什么？
Okay.
你的什么？什么？
Now, this is the equation, right? The fractions. And you see that
It's one.
you have the common denominator, 2, 2, right? So what you do is you multiply both sides by 2. Yeah, you put a note there, okay? So you can skip a little bit some steps, like 3 over 2 times 2 just equal to 3. 5 over 2 times 2 is equals 5. And the negative 1 times 2 will be minus 1. Okay. Okay. Now you got 1/2, probably you forgot this part, the 1 times 2. Every term should be multiplied by 2. Okay. Okay, every term should be, actually this is a factor. You see, if we have A plus B times C, then you have the AC plus BC. Every term should be multiplied out. Okay, and if we go back, vice versa, then actually it's called a factoring. Okay, from here to here, just multiplication from top to the bottom. But from bottom to the top, in reverse this procedure, we call the factoring. Okay, and now, yeah, so this is a place that you probably make mistakes. Then the answer will be totally different, right? So you can, well, there are 2 terms on the right-hand side. If you don't want to make too many moves, then you just move 5x to the left, okay? And you get a negative number. It's okay, a negative number, right? And clearly, x is going to be 1, okay? And you double check. Now, it's a little bit difficult to check the answer because there's fractions involved, right? But if you have time, you can quickly check the answer also and plug 1 for x into the both sides to see if they're equal or not. Okay. All right, so speaking of this, right?
If I get
So
every
A
question
plus
correct.
B, let me talk about this. equals AC
Then I
plus
have something to
BC,
say.
right? From this
I've gotten
side to this
everyone
side, we
correct
call it
so far.
multiplication. Okay, from here to here, we call the factoring. Okay, so so in the future, we're going to study factoring. We call this is called inverse procedure, right? Find the inverse, reverse procedure. Yeah, it's reverse multiplication. If they already multiply them out, but if there is a common fact, you can take it out. Okay. Yeah. All right. The next problem is going to be 1/3 x minus 1 equals 2x. Okay. Please do this. Okay, so what do you get? 100% sure?
-5.
You see, your sisters have, you can talk to each other, okay, to check their work. Yes. Yeah, man.
-1/15.
I have 4 different answers now. Only one of them is correct. Maybe no of them is right.